Hello everyone, welcome to Success Breeze YouTube channel. Today we are discussing about the Boolean Algebra. Boolean Algebra is a set of rules used to simplify a given expression, logic expression, without changing its functionality. What is this? Means, let's see, if we given a logic expression, we want to minimize this expression with the help of set of rules. It is possible to minimize our logic expression, but without changing the functionality. Without changing the functionality, we can minimize our logic expression. Let's see, one of the disadvantage of Boolean algebra is it is suitable for only the less variable values. Right? Let's see the example. Consider an example. Function f is equal to ab plus ab bar. This is the logic expression. From this logic expression, we want to minimize this expression. This is somehow the final our logic expression minimize equation is f is equal to a. Right? We can discuss more. Let's we understand how it is happening. Let's see. From the equation 1 and the equation 2, from this we can conclude that we are getting how many gates in this first expression? 4 logic gates are used. Where the minimize logic expression, only the one gate is enough to make a function, right? But in this, we are not changing the functionality. The functionality is not changed. Right? Without changing the functionality, we minimize our expression. Let's see some rules. Boolean's law. This is the set of rules, complements and or. Next law is distributive law, commutative law, absorption law, demorph law. Let's learn one by one. From first law, a plus 0 is equal to a. Why we are writing a plus 0 is equal to a? Let's see with the help of example. If we consider if a is equal to 1, when we substitute value a is 1 plus 0 equal to 1, we are getting the 1. So from this we can say that whatever the value of 1 is 1, that is same the output we are getting 1. So if we represent 1 as a, right? Yes, similarly if we consider a 0, then 0 plus 0 equal to 0. Then from this we see that when we given the value of a is equal to 0, then output we are getting 0. So it representing 0 as a, right? Next is a dot of 1, that is equivalent to again a. See, similarly with happened with the AND gate, right? If a is equal to 1, 1 into 1 equal to 1. Similarly, if we consider a is equal to 0, 0 into 1 equal to 0. So, whatever the value of a is given 0, the output is 0. So, it represents 0 as a, right? Next is law is a plus of a. Let we consider with taking a is common. Taking a is common, what we get 1 into 1 is 1, right? 1. That is equivalent to A. That is equivalent to A. Next law is A dot of A. In this law, if we consider by adding 0 to the LHS, if anything is changing here in the expression, no, right? No, nothing is changing when we are adding a 0, no difference, right? So for this 0, I am adding A into A plus A into A bar. So 0 is like, I can write 0 as A dot of A bar. Is anything is changes? No. Okay. Next, I am taking, in this A is common. Here is the, this is the A. It's common. Taking A is common. A plus A bar equal to what I am getting, A into 1. Nothing but A plus A bar from the law of Boolean is 1. So the equivalent, equivalent is equivalent to A, right? Next, A dot of 0. A and into 0. If anything we multiply with 0, A reflect only a 0 only. Okay. Next, A plus of 1 equal to 1. That means the OR operation of A and the logic 1 is always be equal to 1. Next, A dot of A bar equal to 0. A bar is a complement of A. So if any case of one of the input of AND gate is always be 0, then the output of AND gate will always remain 0, right? Next, A plus A bar equal to 1. That means the OR operation of A with complement is equal to 1. Let's we discuss next law is absorption law. In this law, we discuss that commutative, A into A plus B is equivalent to A. This how, let's see. From this expression, I am taking A is common, right? A is taken common. From the A is taken common, what it remained? 1 plus of B. 1 plus of B, whenever we write 1 plus anything, it always be 1. So our answer is A. That is nothing but that expression is equivalent to A. Next, absorption law is with OR gate. A plus A dot of B equivalent to again A. If the same thing we can done with the AND, here we are doing the same step with the OR. If we take A is common, again A plus B is remain 1 only, then our equivalent answer is equivalent to A. Next law is commutative law. Commutative law, which says that order of which the inputs are connected to and does not change, or it's remain as it is or remain same. Let's see from here. we can say that from the truth table, let's consider this input we are interchanging B and A. When the both the input are 0, the output is 0. When the both the input 0 and 1, then output is 1. When the input of B is 1 and the A is 0, the output is 1. If the both the input is 1, the output is 1. From this truth table, we can say that if we change our variable B into A into B, then our output remain same, right? Our output remain same, no changes. Next law is A dot of B equal to B dot of A. From the AND operation, we say commutative law which says the order of which that input are connected to and does not changes, right? Does not changes. When we consider B into A, anything B into 0 into 1 is always the output is 0. Then B is 1, A is 0, the output is 0. If B is 0, A is 1, then output is 0. If both the input is 1, 1, 1 into 1 is 1. If we interchange our variable B into A into B, then our output remains same. There is no changes. Next law is De Morgan's law. These laws are very useful in minimizing the Boolean expression or Boolean function. Let's see the first law of De Morgan's law. As per the law, the complement of A plus B is equivalent to A bar dot B bar, right? Yes. So if we see that from the logic perspective, then this A plus B whole bar is equivalent to 2 input OR gate followed by NOT gate, right? Of 2 input OR gate followed by NOT gate. So we say that if A and B are the input to the OR gate, then the output is equal to A plus B. From the diagram we can clearly see that, okay? And that OR gate is followed by NOT gate. So that if A and B are the input to this OR gate, then the output is equal to A plus B. Then it is passed through the NOT gate, then the output of equal to A plus B whole bar. From here we can see the logic circuit of NOR gate, right, with the combination of NOR and NOT gate. So basically this NOT gate inverter the output, and we also know that this OR gate is followed by NOT gate is equivalent to NOR gate. From the second B equivalent to this NOR gate. That means if we apply A and B input to the NOR, then the output is A plus B whole bar. This equal to left hand side. So similarly, let's see the RHS side. So here A bar dot B bar is equivalent. So here we are A bar this and B bar is equivalent to applying the input A bar B bar to AND gate. right? AND gate. These A bar and B bar signals can generated by passing the input A and B through the. From the second diagram, we can say that we are passing this input through the NOT gate. From the NOT gate, from the NOT gate, right? From the NOT gate, the signal, the circuit is oftenly abbreviated like this, right? That is called as bubbled AND gate. That is known as, this is bubbled AND gate. And that indicates that input signal inverted before the AND gate operation. So as per this De Morgan's law, the NOR gate is equivalent to, the NOR gate is again equivalent to this bubbled AND gate. That is, A plus B whole bar is equivalent to, whole bar is equivalent to A bar and B bar. So next we see the next second law. Okay, here we can see the second law. As per the second law, the complement of A and B is same as A bar plus B bar, right? A bar plus B bar. So first we find, or we see some logic perspectivity. Okay, here the, so A dot of B whole bar is equivalent to AND followed by NOT, right? Followed by NOT. This is AND. So the output of this AND will be equal to A dot B. Output of this AND is A dot B. And this NOT gate inverts that the output. Okay, this NOT gate will inverts the AND output is like A bar dot B bar. That is equivalent to NAND gate, right? That is equivalent to NAND gate. That means if we apply input A and input B to the NAND gate, then the output is equal to A dot B whole bar, right? Next we see the left hand side. This equal to left hand side. Similarly, we see the RHS side. So this bar A bar B bar is equivalent applying to the A bar and B bar input to OR gate. Okay. Next, this A bar and B bar signal can generated by passing the input A and B through the NOT gate, right? As we see that the circuit is equivalent to bubbled OR gate, right? This bubble OR gate, where this bubble inverter the input before the OR operation. That means as per the second law, NAND gate is equivalent to, this NAND gate is equivalent to bubbled OR gate. Let's see one example how we minimize our logic expression with this law. See, this is the expression, or simplify this a b c plus a b bar c plus a b c bar. Let the solution we see. Function f is equal to a b c plus a bar b bar c plus a b c bar. In this expression, can we see a common? Yes, we can see the common. What is it? The b is the common. Let's take the b as common. Here AC is taken as common. Then remain b plus b bar plus ABC bar. Nothing but we saw from the law a plus a bar is equal to 1, right? So b plus b bar is equal to 1. So a c plus dot plus a b c bar. Okay, from this expression, in this expression we are taking again a is common, then c plus b c bar. From this expression again we can, from the law we can again solve a plus a bar b is equal to a plus b. Then our final expression is a into c plus b. This is the final expression of Boolean which minimize our logic expression. This is a minimize terms. This we have taken the common. We have taken the AC is common. Here b plus 1 is 1 remain. Then again we taken the A is common. This is how we minimize our Boolean expression. Let's see the example. AB plus A bar B plus AB. Okay. See, in this expression, as we can say that taking the B is common, right? Here the B is taken common. What it's remain? A plus A bar. Again from the law, A plus A bar is equal to 1. So, next, keeping this A into B bar as it is. Next, B plus B into 1 plus A B bar. Our next from this equation, can we consider another law from this expression? Here we can say that A plus BC, A plus B into A plus C. That similarly here we applying this law. I can get this A plus B into B plus B bar, right? Then similarly, as we know that B plus B bar equal to 1, so B plus A into 1, that is equivalent, or B plus A is equivalent to then A plus B from the commutative law. Then we can write A plus B. This is our final minimized Boolean expression. Without changing its functionality, we can minimize our logic.